Okay, let's talk about something that feels like straight-up magic, but is something you use every single day, your touchscreen. We tap, we swipe, we pinch, but how does a flat piece of glass actually know what we're doing? Let's break it down.
Seriously, think about it. You probably do this hundreds of times a day without even a second thought. But have you ever really stopped to wonder how that simple, smooth piece of glass knows precisely where your finger is? It's not magic, but honestly, the science behind it is just as cool. So, how does it all work? Well, it turns out that pretty much every touchscreen you've ever used boils down to one of two really big ideas. It's a choice, really, between sensing physical pressure or sensing the tiny bit of electricity that's naturally in your body. You know, this stuff didn't just appear overnight. The journey to the phone in your pocket has been a long one. The very first finger-operated screen was invented way back in 1965. A huge leap forward came in 1973 from CERN, of all places, with the first transparent capacitive screen. But it wasn't until 2007, with the launch of the original iPhone, that this specific type of screen absolutely took over the world. Okay, so this brings us to the two main players on the field. On the left, you've got the old-school tech, resistive screens. These work by physical pressure. You literally have to push two layers together to make contact. Think of an old ATM screen or the checkout at the supermarket. You can use your finger, a glove, the corner of a credit card, anything works. But on the right, we have what's in your pocket, capacitive screens. They use your body's electricity to mess with an invisible field on the glass. This makes them way more sensitive, but there's a catch. They only work with things that are conductive. I love this analogy for how those older pressure-based screens work. Just picture two slices of bread, and you've smeared peanut butter on the inside of both. To make them register a touch, you have to press down hard enough for the two layers of peanut butter to actually make contact. It's simple, it's rugged, and it gets the job done. All right, so that's the old stuff. But let's get to the main event, right? The screen that's in your pocket, right now. We're going to go inside your smartphone and really understand the amazing science that makes every single tap possible.
So here's the four-step dance that happens in a split second every time you touch your phone. First, there's an invisible grid of wires on the screen holding a constant electric charge. Step 2, your finger, which is a great conductor, gets close. Step 3, your finger actually pulls a tiny amount of charge from that grid, creating a little dip in the electric field. And finally, Step 4, a controller chip is watching this grid like a hawk, and it instantly calculates the exact XY coordinate of where that dip happened. And this happens hundreds of times a second.
So, if you want the super simple version, it's this. Your finger basically steals a tiny little bit of electricity from the screen, and the phone is smart enough to measure exactly where that tiny theft took place. That's your tap. All right, so we've figured out how the screen sees one finger. That's cool. But what about pinching to zoom, or typing with two thumbs? That's the real magic, isn't it? The multi-touch miracle. And that really is the million-dollar question. If the whole system is just on the lookout for a single disturbance, a single dip in that electric field, how on earth can it possibly track 2, 3, or even 10 fingers at the same time without getting totally confused? Well, there's a fantastic analogy for this. Imagine that electric field on your screen is like a perfectly still, calm pond of water. If you touch it with one finger, you create one set of ripples. If you touch it with two fingers, you create two distinct sets of ripples, and the phone's brain can see both of them perfectly. So what's the secret sauce? It's that grid we talked about. It's not just one big sensor. It's made of thousands of tiny intersection points, where those X and Y lines cross. The controller is monitoring every single one of those points independently. So when you use two fingers, it just sees two separate disturbances at two different intersections. It's not one big measurement, it's a whole matrix of thousands of tiny ones happening all at once. It really is an amazing, elegant system, right? Except for when it doesn't work, and we have all been there. So let's talk about those frustrating moments when your screen just won't listen, and how it all comes back to some really simple physics. Okay, here's the classic winter problem. It's freezing outside, you've got your gloves on, your phone rings, you try to swipe to answer, and nothing. Zip. Why? What's going on? The answer is super simple, and it all comes down to one word: conductor. Your screen is waiting for something that can conduct electricity to come along and mess with its field. Your finger is full of salt and water. It's a great conductor. But the fabric of your gloves, or the plastic of a regular pen, those are insulators. They block the electrical connection, so as far as your screen is concerned, nothing is there. Okay, but what about the opposite problem?
You know, the accidental butt dial from your pocket? Well, your phone is actually working pretty hard to stop that from happening. It has proximity sensors to know when it's up against your face during a call. It has special pocket mode software to prevent accidental taps. And it even has palm rejection algorithms that are smart enough to ignore the side of your hand when you're trying to write with a stylus.
And if you were wondering which of those two technologies, resistive versus capacitive, actually won the war, well, this chart says it all. Look at that. By 2018, capacitive screens had taken over a whopping 70% of the market, and those old-school resistive screens down to just 3%. That massive shift is exactly why our phones feel so incredibly fluid and responsive today.
So we've pretty much mastered the tap and the swipe. It feels like second nature to us now. But you know technology. It never ever sits still. So what's next? What comes after the swipe?
What's wild is that a lot of the future is already starting to show up. We're seeing foldable phones with flexible touch panels. We've got fingerprint sensors that live underneath the display itself. There's even force touch, which can tell how hard you're pressing by measuring tiny little differences in that electrical field. And the next big leap might be getting rid of touch altogether and moving to gestures, where you just hover your hand over the screen.
And that really leaves us with a final, fascinating thought. A whole generation of us learned how to tap and swipe because the technology demanded it. It literally changed how we use our hands to interact with the world. So the big question is, what's the next generation of interfaces going to teach our hands to do? What new gestures are we all about to learn?